Right. We're going to try to solve the flowiness equation in indices. But before we do that, we'll try to have an idea of what indices is. Yeah, because you can't solve that without knowing some of the basic laws governing indices. So let's try by knowing the laws. So from the laws, we can now know how to apply the law or the laws of indices. So we'll start with the laws of indices. Let's say laws of indices. So number one law of indices is multiplication law. Say if you have a raised to x times a raised to y is basically saying or is equal to a raised to x plus y. So our second law, law 2 is going to be division law. A divided by ax by a raised to y is basically a raised to x minus y. I'm going to say third law, exponential law. So we have a raised to x all bracket raised to y, something as saying a raised to x times y plus a raised to x y. So also the fourth law I'm going to put up there is say law of zero. Let's say a raised to 0 is equal to 1. So anything raised to 0 is equal to 1. Let's put number 5. Let's put negative indices. So if I say a raised to minus 1 is a negative power. So I'm converting to positive power by dividing by 1. So it's going to be equal to 1 over a. So the sixth one I'm going to do is have a raised to 1 over y, something like saying the y root of a. So these are the basic laws of indices. So I'm going to do some examples using the law to enable us have an idea of how to apply the laws of indices. Alright, let's do some example on how to apply the laws of indices. So let's say example. Simplify. Simplify the following. So let's do the first one. First one. Let's say 2 raised to 5 times 2 raised to 3. So we're doing 2 raised to 5 times 2 raised to 3. So basically, let's say that 2 raised to 5 is something like saying 2 times 2 times 2 times 2 times 2. And then 2 raised to 3. That's saying 2 times 2 times 2. Therefore, 2 raised to 5 times 2 raised to 3 will be equal to 2 times 2. So that's the first one. And 2 times. So which is equal to 2 raised to 8. So by the laws of indices, 2 raised to 5 times 2 raised to 3 will be equal to 2 raised to 5 plus 3, which is equal to 2 raised to 8. So it's the same. So the law of indices corresponds the nominal way we do it. So we'll take example 2. If I say the same, 2 raised to 5 divided by 2 raised to 3. So it's going to be, this should be equal to 2 raised to 5 all over 2 raised to plus 2 times 2 times 2 times 2 all over 2 times 2 times 2. So we can just cancel out. These two can cancel these two. This one can cancel this one. This one can. So therefore we have 2 raised to 2. So which also could mean that 2 raised to 5 divided by 2 raised to 3. So I'm not saying 2 raised to 5 minus equals to 2 raised to 3. So it corresponds with the nominal way. So the second law. Let's take the third law. Let's simplify 2 raised to 3 all square. So normally it's supposed to be 2 raised to 3 times 2 raised to 3. So that's the square means into 2 places. So which will be 2 raised to 2 times 2 times 2 times 2 times 2 times 2. So which will be equal to 2 raised to 6. 1, 2, 3, 4, 5 is equal to 2 raised to 6. So which also means that using the law of indices, 2 raised to 3 or raised to 2 is not the same 2 raised to 3 times 2, which is equal to 2 raised to 6. So corresponds with the laws. So we'll take the fourth one. Take the fourth law, that's the number 4. So 2 raised to 3 divided by 2 raised to 3, which is equal to 2 times 2 times 2 all over 2 times 2 times 2. So if I cancel out, so this divided by this is going to be 1, cancel this by 1, 2 divided by this is going to be 1. So 1 times 1 times 1 is equal to 1. But also by law of indices, we know that 2 raised to 3 divided by 2 raised to 3 is equal to 2 raised to 3 minus 3, which is equal to 2 raised to 0. So when you use the law of indices here, we'll get 0. When you do number 1, so which means 2 raised to 0, same thing as 1. Because the answer gives us two answers. So which means either I say that 2 raised to 0 or you put it as 1. So anything raised to 0 is 1. That's the fourth law. Alright, let's do the fifth one. Fifth one. Okay, so the fifth law is the law of negative law. Okay. So let's say, look, let's say 2 raised to 3 divided by 2 raised to 5. So by virtue of the law of indices, it's going to be 2 raised to 3 minus 5 equal to 2 raised to minus 2. Yeah, so but if you say 2 raised to 3 divided by 2 raised to 5 to mean 2 raised to 3 over 2 raised to 5, which is equal to 2 times 2 times 2 is all over 2 times 2 times 2. So if you cancel out 1, this cancel this one is 1, and this cancel this one is 1. So it is equal to 1 all over 2 times 2, which is equal to 1 all over 2 raised to 2. So this turns, so therefore 2 raised to minus 2 can be written as 1 over 2 raised. So that's the fifth law. Alright, so the last one, sixth law, is what's number 6. So if I have 2 raised to, okay, let's say 4 raised to 1 over 2. So based on the law, it's something as saying the 2 raised to 4, which is like the square root of 4, which is equal to 2. So 2 raised to 1 over 2 is like the square root. So another example you can say is this 8 raised to 1 over 3. Something as saying the cube root of 8. And cube root of 8 is equal to 2. Cube root of 8 is 2. So, but you can also solve it using indices. The other ways you can solve it, you can say 8 is, so if can also solve it, 8 raised to 3 could mean 8 is 2 times 2 times 2. Let's say all raised to 1 over. Let's now say 2 raised to 3 bracket 1 over 3. So using the third law, it will be 2 raised to 3 times 1 over 3. So this can cancel equal to 2. So there are many ways you can solve that. So having known these laws, we can now go ahead to try the equation given, our initial equation. So let's do the first one. Let's do the first equation. I'm going to just move it line. So the first equation is, number one equation we had was 2 raised to 2x plus 1 minus 9 raised to 2x plus 4. Yeah. So first thing we're going to do is solution. First of all, you know that this first one, 2 raised to 2x plus 1 is something as saying 2 raised to 2x times 2 raised to 1. Consider the base were the same, they added the power. So minus 9 raised to 9 plus 4. So I'm going ahead to change this equation to 2 raised to x or square. So this equation just be converted. It's the same thing. Either 2 raised to x or 2 raised to x2, they're all the same. So times 2 raised to 1 minus 9 2 raised to x plus 4. So I'm going to use another letter to represent 2 raised to, have 2 raised to s here. So let's say let y represent 2 raised to s. So which means anywhere you see 2 raised, or you put y. So what we're going to have here is, so y square times 2 minus 9, this is y now, 9y plus 4. So multiply this is going to be 2y square minus 9y plus 4. But remember, we're not looking for y, we're looking for s, but just using y to make the equation solvable, so solvable, so we can solve it easily. So I'm going to go ahead to factorize, because the quadratic equation now can factorize the equation. And for you to factorize quadratic equation, I want to give a little light on how to factorize that equation. For you to consider this type of quadratic equation, you can first of all multiply 2y squared multiply with 4. So going to first, my step 1 is factorization is to multiply first and last letter. It will be 2y squared times 4. What I'm going to have 8y squared. Have 8y squared. I'm going to have. So I'm going to look for, so step 2. What step 2 is to look for two numbers that when you multiply them, you get 8y squared, or you get 8. When you add them, you get 9. So the two numbers you can multiply and get 9 is minus 1 and minus 8. So you should have minus 1 and minus 8, because minus 1 times minus 8 is 8. Minus 1 plus minus 8 is minus 9. So having all the two numbers, so what I'm going to do, so I'm going to step 3 to replace. So step 3. So step 3 replace 9 iy with with my minus y and minus 8y. So for it to change this number now, so it's going to be minus y is something, one is something as y because you can't put one y. So I'm going to go ahead to replace it. So I have, therefore have 2y squared minus y minus 8y plus 4, they all equals 0. So we're going to go ahead to factorize. So we're going to go ahead to factorize this one now. So I will just group them. So as the first to group the equation. So just group the equation. So what I had to say 2y square minus 1. I'm going to group this one. Minus, going to say, so when there's a minus sign here, when you put a bracket, this plus is going to change to minus. So we're going to have 8y minus 4 equal to 0. So take the common factor. As common factor here is y. That's y. So if we take one y out here, we're left with 2y, but that will be 2y minus. So y out of here is not going to be 1 minus. So the common factor here is 4. So if I say 4 into 4 out of here, going to be 2y. 4 divided by 4 will be minus 1. So now we have two common equations, so we can just take the multiply. So we had y into 2y minus 1 minus 4 into 2y minus 1. So what I'm going to have here now is, so taking the multiply away, you're going to, because they have common factor, going to be y minus 4 into 2y minus 1. So which means y minus 4 is equal to 0, which implies y equal to, when 4 goes here becomes plus 4. Also 2y minus 4 is equal to 0. To which implies, so we'll take 2y is equal to 1. Therefore y is equal to 1 over 2. So our values for y so y is equal to 4 or 1 over 2. So when we're looking for x, I will know that y originally, from the previous equation, y is equal to 2 raised to x. Now, so when y is 4, we have that 4 is equal to 2 raised to x. And we know that 4 is something as saying 2 raised to 2 equals to 2 raised to x. So since the base are the same, we can cancel ourselves for 2 equals to x, which implies s is equal to 2. So when y is equal to 1 over 2, it then means that y is equal to 2 raised to x, and so y is 1 over 2 now becomes 1 over 2 is equal to 2 raised to x. And we know that 1 over 2 is something as imply 1 over 2 is saying 2 raised to minus 1 is equal to 2 raised to x. For 1 over 3 something as a negative index. So since the base are the same now, have minus 1 and s, so we can cancel, 2 can cancel, have minus 1 is equal to s. So our x is equals to 2 and minus 1. So that is how we can solve the first equation. Right. So we'll continue the other question in the next lecture. Thanks.